Hello everyone, welcome to my video tutorial on AWS Lambda. This video will teach you everything you need to know about Lambda and get up and started with AWS Lambda. Before I start my tutorial, I'm a blogger and I write my blog at techieandtravel.com. Do check it out. Also, if you like my YouTube video contents, do like, share and subscribe. So let's look at the overview. In this tutorial, we'll talk about what AWS Lambda is, supported languages, why to use the Lambda service, its costs and limitations. We'll talk about IAM roles and policies that you need to successfully create the Lambda workflow. And finally, we'll write our own Lambda function and deploy it in AWS. But first, let's talk about the Lambda service in detail. AWS Lambda was launched in 2014 by Amazon. Before Lambda, the traditional way to deploy applications was to create and manage servers and deploy those applications on those servers. With Lambda, you don't need to maintain any servers, but rather just focus on the application code. And AWS will maintain the underlying compute infrastructure like server, networking, storage, etc. So basically, it's a serverless computing in which the cloud provider allocates the compute resources on demand. So you define specific functions. You write a code and you define those small specific functions that you can trigger to run the code in AWS Lambda. And Lambda acts as a lightweight execution engine for this function. There are two main methods to invoke the Lambda function. They are event and request or response. Event execution method is used when you perform a function based on triggered events. Like you can say, when there is a object placed in S3 bucket, execute this function. Or when there is a DynamoDB table update, just execute this function. And request and response method is used when you expect response from a request. For example, when integrating with AWS API Gateway. Let's look at the supported languages. The code that runs inside Lambda functions can be created in any of these languages: Node.js, Python, Java, C#, that actually runs on top of .NET Core runtime, and Ruby. This means that you can use your own language of your choice to create all the applications without provisioning any servers. So why use Lambda? There are several benefits of using Lambda, the first one of which is serverless computing. It eliminates the need to manage the infrastructure. So you can just create a function and let Amazon handle the rest. This is also a function as a service, which means we can develop functionality without the complexity of building and managing the infrastructure. The other benefit is its scalability, where it can dynamically scale capacity in response to the increased traffic. Other main advantage of Lambda is that it's cost effective. You pay as you go and you pay only for what you use. Unlike in EC2 instances, which will cost you even if it's idle, and you will pay for the actual runtime with Lambda. Another main benefit of Lambda is its event-driven workflow. For example, you can say that when I upload a file, execute this function. Another main advantage is that its integration with other AWS services. So we can use API Gateway to provide a secure and scalable gateway for web APIs that routes HTTP requests to Lambda functions. Or we can define Amazon S3 events that invoke a Lambda function. We can also use Lambda function to process the Amazon SQS messages or Amazon simple notification service notifications. So basically, it provides several integration with the other AWS services. Now let's look at the Lambda costs and pricing. Lambda functions are generally charged according to two factors: the amount of requests carried out and the work undertaken to carry those requests. Initially, AWS Lambda provides free tier usage with 1 million free requests per month and 400,000 GB seconds of compute. When you run through your free tier usage, requests are then priced as 20 cents per 1 million requests, that is, a cent every 50,000 requests. Usage time is charged according to GB seconds. So in the US East region, the cost is 0.00001667 per GB second. So the duration is measured in gigabyte of memory per second increments. For example, if I have a 1 GB per second, it means that I can run a Lambda function that uses 1 GB of memory for exactly 1 second. Or I can run one function that has 500 MB for 2 seconds. In addition, for paying for the requests and duration of Lambda function, there might be some additional costs, like you might have to pay for data transfer, and if your Lambda uses other AWS servers. As you know, AWS Lambda works by executing the function in containers. There are some limitations of AWS Lambda. So the maximum execution duration of this AWS Lambda function cannot exceed 15 minutes. And the memory allocation is in between 128 MB to 3 GB of memory. Although 3 GB is sufficient for many scenarios, but keep in mind that if your function uses more than 3 GB, then your instance would be terminated. Also, one important thing is that you cannot allocate CPU to your Lambda functions unlike in EC2, but instead, the available CPU for your Lambda function is directly correlated to the amount of memory allocated. The more memory you use, the more performant your function will be. So there is a limit on the number of concurrent Lambda functions that is executing in the same region. But you can contact Amazon to increase this number. The ephemeral disk capacity that is under /TMP is 512 MB. So each Lambda has temporary storage which can store up to 512 MB of data. This storage will be deallocated once the function is complete. Another limit is on the deployment package size, which is 250 MB for the unzipped and 50 MB for the zipped package size. The function package in a region should be less than 75 GB. So now let's look at the Lambda scenarios. First, you upload your AWS Lambda code in any AWS supported language. Lambda can run your functions when triggered by events from different AWS services, and Lambda executes the code when it's triggered, and the Lambda function runs this or executes it in a container. Each Lambda function runs its own container, and when a function is created, Lambda packages it into a new container and then executes the container. And you are only charged when the code executes. So what are the popular triggers that can happen? For example, any change in the S3 bucket, any update to the DynamoDB tables, some push notifications, hosting of websites, etc. So basically, in a serverless model, user needs to organize code into Lambda functions, and each Lambda functions runs its own container. So before the function starts running, each container is allocated its necessary RAM and CPU capacity. Once the function finishes running, RAM allocated at the beginning is multiplied by the amount of time the function is spent running, and then customers gets charged based on the allocated memory and the amount of RAM time the function took to complete. You can invoke your Lambda function using the Lambda API, or Lambda can run function in response to events from other AWS services. So in summary, Lambda function is a program or script that runs in AWS Lambda. Lambda then passes the triggered events or the invocation events to your function, which processes the events and returns its response. Now let's look at the Lambda function structure. Lambda function has basically few requirements. The first requirement you need to satisfy is to provide a handler. So handler, it's the entry point for the Lambda. So let's look at this example. This function has a handler name, and handler method has events and context as parameter. After we do all the work inside Lambda function, we simply return it with results. The event object has details of the event which triggers the Lambda function. And second parameter, context, it provides the runtime information that our Lambda function is executing in. So once a function is written, the most important thing is a trigger. A function can be invoked or triggered every time there is an upload to S3, for example, or there is a DynamoDB table change. Or function can respond to requests such as to API gateway or based on some CloudWatch trigger. These Lambda functions, they need to be packaged and sent to AWS. This is usually a process of compressing the available function and all its dependencies and uploading it to a bucket, and then letting AWS know that we want to use this package when a specific event takes place. And then, as described earlier, every time this Lambda function is triggered by an event, it is invoked in a new environment in a separate container. So Lambda is smart enough to scale the containers up and down depending on the amount of requests. This is a sample example of a Lambda function that returns hello from Techie and Travel. So let's look at the ways of how to create a AWS Lambda function. You can either create AWS Lambda from scratch, or you can use the existing blueprint. These blueprints are examples of some working Lambda functions which can be quickly configured and used. There is also a serverless application repository, which is a collection of serverless applications that are published by developers, companies, and partners in the serverless community. And since 2020, AWS supports container packaging of Lambda function as well. So you can package your Lambda function code and dependencies as a container image rather than updating it as a zip. So when invoked or triggered, the functions deployed as container images are run as is. So in this tutorial, we'll use one blueprint function to demo the Lambda function, and then we'll create our own function to back up a S3 bucket when the data is updated in it. Primarily, we'll create a bucket and we'll upload an image to the primary bucket that would trigger a Lambda function and then place it in the secondary bucket or in the backup bucket. Obviously, we would need roles and policies defined for Lambda function to be able to access the S3 buckets. So basically, this is what we are going to do. Creating a bucket and then create suitable IAM roles and policies, create a function and attach those policies to the function, and then add a trigger for the Lambda function, which is to update an object in the bucket. Finally, we'll add a code to the Lambda function. Let's look into the AWS Management Console. Here I'm in my AWS Management Console. In the search section, I'll search for Lambda and then I'll click Create Function. As I said earlier, you can either create from scratch or use a blueprint. You can also create a container image and then you can browse the serverless app repository for the sample Lambda function. But for this tutorial, I'll be using a blueprint and then creating our own Lambda function from scratch. So first, let me use a blueprint. I'll click on blueprint and then search for Lambda Canary. I'll click on it and I'll select it. I'll click on configure. I'll set a name for my first Lambda function to be my first Lambda function. For this specific Lambda function, I would choose create a new role with the basic Lambda permissions, and then I'll show how to create roles and policies in the next set of function. And here I'll go ahead and create a new rule. In this new rule, I would select a rule name to be my Lambda, and then I would set a rule description to be first Lambda function, and then make sure to click on the schedule expression and then choose the expression. Here I choose the rate of 1 minute. Now you can see there is a sample Lambda function which you can update after you create a function. Then I'll go to the environment variable section. Over here there are two key parameter and two value parameter. This specific function, it looks for the contents in the website and then triggers a function as per that. So for the sample purpose, I would choose my blog site techieandtravel.com, and then I would select a random keyword for the expected keywords which should fill the triggered Lambda function, and then at the end I would choose create a function. So we created a function from the Lambda blueprint using the basic set of roles that would be enough to create the function and to execute the function. After successfully creating the function, I would click on test and provide an event name as my test function. And then I would go ahead and choose create. Once the function is successfully created, I'll go ahead and click on test. As you see in the expected result section, the check failed. It checked for my site techieandtravel.com over here, and then it failed to get the keyword. If you click on the configuration section, you can see that we created our trigger with the schedule expression rate of 1 minute. You can also click under the test section and then click on test. You would see that the expected result is failed because the keyword that we specified in our event trigger isn't present in the website. Now let's redo the same function by providing a keyword that is expected in my website. Click on the configuration and click on the environment variables. Over here, click on edit and then provide a keyword that I know is present in my website, which is administrator. Click on save and then re-click on the test and click on test. As you see, now the status is succeeded. because we provided a keyword in the environment variable and it went ahead and checked the website and found the keywords. So this was an example of using the available blueprint from the Lambda and testing our function. Next, we'll go ahead and create our own Lambda function, which checks for the new added object in the S3 bucket and backs it up in the secondary bucket. Let's go ahead and do that. Now we'll go ahead and create a second Lambda function with this scenario. For this, we need to create a S3 bucket, create IAM roles and policies, create Lambda function, attach policies, and then add a trigger to the Lambda function. Then finally, add our code to the Lambda function. Let's do it. Here I'm in my AWS management console. The first step is to create two S3 buckets. Let's go ahead and do that. I click on S3. Let me create a bucket named Techie Bucket 1 and create it. And then similarly, I'll create a secondary bucket called My Secondary Bucket 1. Now I see two buckets are created. As you see, my buckets are created in central region, so I need to make sure my Lambda function is in the same region as well. So next, we would need to create a roles and policies for our Lambda function. Let's go to the IAM roles and policies. Click on IAM, click on roles, and click on create role. Since we are going to use a Lambda function, click on Lambda and then click on next. We need to attach a policy to the Lambda function. For this specific purpose, I need my Lambda function to access the S3 bucket. Let's search for the existing policies. And here I can see that Amazon already provides me a policy called AWS S3 full access. So for the testing purpose, I will use this specific AWS policy. You can create your own policy. I have a detailed explanation in my video for IAM roles and policies. Do check it out. For this specific purpose though, I will attach this specific policy that provides me access to the S3 bucket. Click on next, and then I'll give it a meaningful name such as my test role Lambda, and then click on create role. As I see, my role is now created. Now I'll go into my Lambda service and then create a Lambda function. Here in the function section, click on create function. Since I'm using my own code, I'll click on scratch and then provide a function name. Let's call it a test Lambda function. I will choose Python as my runtime. As discussed in my earlier tutorial, there are several supported languages. You can choose any of the languages, but your code needs to be written in that language and support the runtime. I'll choose Python, and then under the permission section, I would choose use an existing role and then attach the existing role that I created earlier, which is my test role Lambda. Let us create a function by clicking on create function. Over here, you see that you have a function created with some default entities. As we know, Lambda function has a handler section which has event and context, and then we would need a trigger for this function to work. First, let's add a trigger. We'll select a trigger for S3, and then under the bucket section, we'll choose our primary bucket because we want a trigger to happen when an object is placed in the primary bucket. For the event type, you can select any of the event type, but for the testing purpose, I'll select all object create events. So this prefix section is optional, where you can select the specific directories within the S3 bucket or any specific file systems like JPG, PNG. But since this is optional, I'll leave it as it is. I'll acknowledge it and I will add a trigger. So now you will see that we have a trigger and the event type is object created. So anytime an object is created, this trigger will happen. Now let's go into our code and update our function. I'll delete this, and then for the test function you can go into my website techieandtravel.com, click on blog, and then select AWS Lambda function to backup S3 bucket. I have a sample function in here that you can use as a template. Let's copy this and paste it in my Lambda function. So this is a simple function that defines the Lambda handler that has a source bucket and the object key variable. And then I have my target bucket specified as my secondary bucket 1 that I created earlier. So in the response section, I have S3 copy object for the target bucket, which is my secondary bucket, from the source, which is my primary S3 bucket, and it will return the response. So once that is done, you click on deploy. Now it's deployed. Now we'll go and test our function. Since our function was created to back up the object that is updated in the primary bucket, I'll go ahead in my primary bucket. Since we have a function that will be triggered whenever there is an object updated into the primary bucket, and then it backs it up in the secondary bucket, let's make sure that we don't have anything in the secondary bucket as well as the primary bucket. Now I'm in my primary bucket. I will upload a sample test file. Since we haven't defined anything related to the extension of the file, let's update it. We'll see that upload succeeded. Now let's go into our secondary bucket. We'll see the exact same build.jpg that we updated in the primary bucket is uploaded into the secondary bucket, because our function is triggered as soon as we updated the object in the primary bucket. So this is it on the tutorial for the basics of Lambda function. I will cover the detailed functions use cases in my next video. If you guys are interested in it, do comment it out in the comment section. And if you like my video, do like, share, subscribe, and comment on it. Thank you.